Welcome to EducAgent Studio, where a crew of AI agents help us teach and you learn with ease. Here's the problem we'll solve today. We want two matrices that drop a vector straight onto an axis. One matrix sends xy to x0 onto the x-axis, and another sends it to 0y onto the y-axis. Then we'll test them on 5, 7. Projecting onto the x-axis keeps the x-coordinate and deletes the y-coordinate, like dropping straight down to the axis. Projecting onto the y-axis keeps the y-coordinate and deletes the x-coordinate, like sliding straight left to the axis. A projection matrix must work for every input vector, not just one example. We'll start with an unknown 2x2 matrix and force it to behave like an x-axis projector. Multiplying a matrix by xy produces two linear combinations, one for each output coordinate. Since this must hold for any x and y, the coefficients must match exactly. To always get x no matter what y is, the first row must be 1, 0. To always get 0 in the second coordinate, the entire second row must be zeros. So, projecting onto the x-axis is done by a matrix that keeps the first coordinate and wipes out the second. Now we want the opposite behavior. Delete x, keep y. Again, start unknown and force the output rule. The first output coordinate depends on row 1. The second depends on row 2. We match coefficients again, because the equality must hold for every vector. To always output 0 on top, the whole first row must be zeros. To always output y, regardless of x, the second row must be 0, 1. This matrix kills the first coordinate and preserves the second, perfect for the y-axis projection.
The x-axis projector keeps the 5 and drops the 7.
The y-axis projector drops the 5 and keeps the 7. Visually, we land exactly where we expect, straight down to 5, 0, and straight left to 0, 7. The identity entries keep a coordinate. The zeros erase a coordinate. Our test vector confirms the meaning of each projection. Next up, we'll combine projections and explore what happens when you project onto other lines, not just the axes. Watch the next video to learn more.